What's your phone password?
Wait, why don't we...
What's your iPhone password?
These are necessary.
What's your phone password?
Wait, I don't want to say that.
Mr. Ewing, what's your phone password?
26385.
Oh, it's you.
It's very difficult to guess people's phone passwords because there are just so many possible combinations of numbers. For example, if we take an Apple iPhone that has a 4-digit passwords, there could be so many combinations such as 1, 2, 3, 4, 5, 6, 7, 8, or basically any combination of any 4 numbers. Therefore, if we break it down and try to find the number of possible combinations, there would be 10 possibilities for the first number, as the first number could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, which is 10 numbers. Therefore, there are 10 possibilities for the first slot. And because in a phone password you can use the numbers as many times as you like, and it can be a random array or like generated numbers, then the numbers, then it would be the same case for the next 3 numbers. And this is also called a permutation, which is an arrangement of objects in a definite order, because you have to click the numbers in the correct order for it to be correct. And if we multiply these together, the result will be the total number of phone password combinations, which in this case is 10,000, because it's 10 times 10 times 10 times 10 possibilities in each slot. However, this number changes depending on the limitations given in each slot. For example, if Mr. Ewing says his phone password starts with a 2, then this number changes as the number of possible numbers in the first slot changes. For example, his phone password could be 2345 or 2468 as long as the first number is a 2. Therefore, there's only one possible number that can be in the first slot, which is 1. However, there are no restrictions to the other 3 numbers left in the password. Therefore, there are 10 possibilities in the second, third, and fourth slot, as it can be numbers ranged from 0 to 9. Therefore, if we multiply these together, then there are 1,000 possible combinations that could be Mr. Ewing's phone password. The formula for permutations can be given as n factorial over n minus r factorial, where n are the total number of objects and r are the number of objects you want to select. Therefore, if we give an example where there are 5 books in a collection and you want to select 3 out of those 5 books, when you use this formula, it would be 5 factorial over 3 minus 5 factorial, which would be 5 over 2 factorial, which would be 60. Therefore, there are 60 different combinations of 3 books you can select out of these 5 books if the order matters.
90% of gambling addicts quit right before they're about to hit it big. A slot machine essentially operates on a number of random number generators. If we assume, for example, that each roll is made up of numbers from 1 to 100, and each time the generator lands on a multiple of 10, an image will line up. Here, if we assume that the slot machine is made up of 3 slots, there are a couple different options of how you could win. For example, if all 3 numbers that are generated are multiples of 10, the player will win a prize. The jackpot, for example, could be when all 3 of the slot numbers are the same multiple of 10. Then the player will win the jackpot prize as illustrated in this example here. The respective chances of the prizes would be as follows. For any prize at all, which is the case in which all the slots are properly aligned with images, you would multiply 100 choose 10 3 times as there are 3 different slots. Alternatively, the jackpot would be calculated by 100 choose 1 multiplied 3 times, then multiplied by 10 for the 10 options of numbers which satisfy the alignment of the slots. So these were just a few examples of how combinations and permutations work in real-life examples. Thanks for watching.